Hello, welcome to Chapter 7, Section 4, Properties of Logarithms. One more time, textbook page 516, PDF page 31, and we're going to do problems 11, 12, 13, 14, which are the guided practice problems, which are the ones I usually do in class anyway, just like the homework problems. All right, one thing, again, I guess the parentheses are still an ongoing problem, so I like to put parentheses around that. I've got the parentheses here. I'm going to put parentheses around that. But this one, that looks a little complicated, because here's what's happening. And this problem, the whole thing is in parentheses, and this whole x over 2 plus 5, that is the exponent. They're just being cute. Don't panic. What this means is 2 to what power, I'll write it over here, 2 to what power equals 2 to the x over 2 plus 5 power. If the bases are the same, then the exponents have to be the same. This is an inverse property. If the bases are the same, if the base of the logarithm is the same as the base of the exponent inside the logarithm, then you just give me the exponent, if I can get my marker to right. This is just x over 2 plus 5. That's all it's asking. And I know this is really, think of it this way. Log base 2 of 2 to the n power just equals n. That's all that it's doing. Whatever that exponent is, the logarithm is literally asking, what's the exponent? The exponent is n. So what's the exponent? The exponent is x over 2 plus 5. They're just being cute with x over 2 plus 5. Well, let's make it more complicated, right? You don't have to do that. Number 12. My base of my exponent is 2.5. This right here is my exponent. That logarithm also has a base of 2.5. That just equals 19. If the bases are the same, then what's inside my logarithm, the input of my logarithm, becomes the value. That's it. Nothing more. This one's a little bit more complicated. Now, what I want to do is I want to say, well, 4 to what power equals 1024? We didn't do the powers of 4. We did the powers of 2, and you should be able to skip every other one to get the powers of 4. So it was there the whole time, always was. But in this problem, we're actually supposed to find the power, the inverse properties. I'm sorry, I almost said power property, which actually you could use that also. So I could write it this way: 4 to some power. And then I got to figure out what the power is, all right? So do 4 to the first power is going to be 4. 4 to the second power is 16. I could have skipped that. 4 to the third power is 64. 4 to the fourth power is 256. And 4 to the fifth power is 1024. By the way, just a little bit of an aside. 2 to the 10th power equals 1024. 4 to the fifth power equals 1024. That's the same as 2 to the second power to the fifth power. Think about that. And you didn't see that because I didn't have it on the screen. That was supposed to be mind-blowing. I didn't even have it on the screen. So this is my exponent 5, and of course, that just means 5. Now, this one, this one gets a little tricky, maybe. Notice that, like, if I have a base 2 and a base 2 here, base 2.5, 2.5 here, 4 and 4, I did that. I don't seem to have that here. But I do know, I'm going to write it down here, 0.5 is the same as 1/2. And 1/2 is 2 to the negative 1 power. Aha! So I can write it like this: log base 2 of 2 to the negative 1 power to the fourth power. And like you see me do with other problems, actually in the previous video where we're doing the power property, I can multiply these exponents. Log base 2 of 2 to the negative fourth power gives me negative 4. So when it's all said and done, after presenting you with a whole bunch of different tools, you should be able to simplify a lot of different situations using logarithms. And this is important because there are lots of places where we're going to have exponents, and the logarithm is the exponent. So using the properties of logarithms allows us to solve equations where the unknown part is in the exponent. That comes up in chapter 7, section 5, where we start to solve equations. We'll see you in the next video.